Hello, this is Jennifer Martinez, and in this video, we're going to learn how to solve triangles without a 90-degree angle. That means that we can solve now any triangle using the law of sines. So in any triangle, ABC, again, none of the angles need to be 90 degrees. With sides little b, little c, so I'm just going to put the little a across from the big A, the little b across from the big B, and the little c across from the big C. We have that A over sine of capital A, angle A, is equal to B over sine of angle B. Or you can also have it equal to C over sine of C. So you actually have three different choices here. That is, according to the law of sines, the length of the sides in a triangle are proportional to the sines of measure of the angles opposite them. To derive this, we are going to start with an oblique triangle. It can be an acute or an obtuse triangle. That is, again, not 90 degrees. But we're going to create a 90-degree angle by looking at the height here. So we're going to have our angle ABC, which is the same configuration I had on my drawing, and then we're going to look at the height with this acute angle or the height of the obtuse angle. Again, this discussion applies to both triangles. So we're going to first construct the perpendicular from B down to AC, or its extension over here. Same thing, it's still AC. Then C is the hypotenuse of right triangle ADB. And even in this one, here it's ADB. And A is the hypotenuse of BDC, this side. BDC, and on this one as well, BDC. So let's look at triangle ADB. The sine of A, here it is right here, the sine of A is the opposite, which is H, over the hypotenuse, which is C. Or if I solve for H, multiply both sides by C, I get H is equal to C sine of A. In triangle, and by the way, again, that is true for both triangles. If I look at this, the sine for the left triangle is still H over C. So now let's look at the right triangle. In our acute triangle, we have that in triangle BDC, the sine of C is H over A. So multiplying both sides by A, we get H is A sine of C. And again, this is the same. If I look at C on the obtuse triangle, the sine of C, because the right triangle is D, is still H over A. So again, it doesn't matter what type of triangle that you have. Now I'm going to set these two H's equal together because they're both H, the same H. So I'm going to have C sine of A equals A sine of C. And again, just in these H's are the same in the acute case, or they're the same in the obtuse case. And to get our law of sines, I'm going to divide both sides by sine of A and sine of C. If I do it to both sides, then you're going to see that the sine of A's cancel here and we get C over sine of C, and then here the a's cancel, and you get A over sine of A, which was one of our choices here. It was that second middle one. In a similar way, by constructing perpendicular lines from the other vertices, we can flip and rotate them around and do the same thing. We can show that these two equations are also true, that A over sine of A is equal to B over sine of B, and B over sine of B is equal to C over sine of C. So that is where you're going to get all three of them equal to each other. Just so you know, there is an alternate form of law of sines. You can flip each one of these. So you could have said that sine of C over C equals sine of A over A, which is sine of B over B. To see this, we could have set these two equal to each other. Again, C sine of A equals A sine of C, the two H's, starting over here. And instead of dividing both sides by the sines, I could have divided both sides by AC. And then I would have had sine of A over A equals sine of C over C. That gives you the first two equations, and then again, we'd have to reconstruct the triangle with a different perpendicular going down to something different other than AC to get another one, or to get something with B. To use law of sine, you always need to make sure that you have an angle and the side across from it known. So for instance, let's go back to our picture up here. If angle A is known, you would need to know the measure of the side, little a, the side that is across from angle A. Or if angle B is known, is the only one that's known, then you would need to know the side that is across from angle B. We're calling it here little b. And the same thing, if C is only known, then you would need to make sure that you also know C. If more than one angle is known, then you just need obviously one of those to use law of sines. To see this, please check out my next video.